Okay, write down the problem. Write down the problem. A solid cylinder having a mass 8 kilogram, 8 kilogram, and radius 20 centimeter, and radius 10 centimeter is arranged to rotate, is arranged to rotate, is arranged to rotate vertical axis, vertical axis, vertical axis, which passing through the center, which passing through the center, which passing through the center. Mass of 2 kilogram, mass of 2 kilogram, mass of 2 kilogram is connected, is connected by using light-weighted, by using light-weighted inextensible string, inextensible string to the one end, to the one end, and the string passing through the whole cylinder. Okay, it's like this one. Draw this one first. Draw this one. I think it's clear. Yeah, 2 kilogram is attached to the cylinder. It's connected to the cylinder using the string. This is string. The string passing through the whole cylinder. Okay. Then write down number one. Number one. If the angular acceleration, if the angular acceleration, if the angular acceleration of the cylinder is alpha, of the cylinder is alpha, of the cylinder is alpha, and the linear acceleration of the mass is, linear acceleration of the mass is A, simple A, what is the relationship between A and alpha? What is the relationship between A and alpha? What is the relationship between A and alpha? Okay, find out the okay. Write down the second one. Write down second problem. Problem number 2. What is the moment of inertia? What is the moment of inertia? What is the moment of inertia about the axis? About the axis of rotation, of rotation of the cylinder, of the cylinder, of the cylinder. Number 3. What is the angular acceleration? What is the angular acceleration? Angular acceleration of the cylinder of the cylinder of the cylinder, the linear acceleration of the mass, linear acceleration of the mass, and the tension in string, and the tension in the string, tension in the string, and the tension in the string. Okay, okay. This is the diagram. This is the diagram. Okay. It's connected to the 2 kilogram. Is connected to the cylinder using the lightweight string, and 2 kilogram is going down with acceleration, and the cylinder rotates with the angular acceleration, Okay. Then you have to apply the F equals ma to 2 kilogram. This tau equals I alpha to this one. You know the I of the solid cylinder I have given m r square over 2. Okay. Okay. I think clear. Find out. Okay. First of all, we have to get the relationship between the A and alpha. A equals R alpha. We know R equals to 0.2 meters. Alpha equals to A. This is number 1. It's okay. Therefore, the number two is what? Number 2 is A equals R alpha. Number 2 is we have to get the I value. I equals mr square over 2. M means the 8 into R means 0.2 square into 2. That means 0.16. Your answer is correct. Yes. Then we have to apply F equals ma to 2 kilogram to downward direction. We have to mark all these things, direction and the F equals ma, all the things. Okay. Then apply F equals ma. That means 20 minus the tension T. 20 Newton minus T equals 2 into A. We can say A equals R alpha. 20 minus T equals R alpha. 2 into 0.2 alpha. Therefore, we get the 0.4 alpha. Okay. Then we have to apply tau equals I alpha to this direction.
Sir, ඔතන apply, sir.
Clearly mention the all. When we apply the tau equals I alpha, we know torque means the normal moment. T into 0.2. T into 0.2 equals I mean 0.16 alpha. Therefore, we get T into 2, 1.6 alpha. T equals 0.8 alpha. This number 1, this number 2. 20 minus T equals 0.4 alpha. Therefore, we have to add these things. 1 plus 2. Then, therefore, when we add 20 minus T plus T equals 1.2 alpha. Therefore, alpha equals 20 over 1.2. That means 200 into 12. We can divide into 4. 50 over 3. Therefore, 1, 20, 16.67. RAD is minus 2. Yes, your answer is correct. Therefore, we can take T as T equals 0.8. Alpha means the 50 over 3. 50 over 3. Therefore, 40 over 0.88 into 5, 40 over 3. Therefore, 1. Yes, your answer is correct. 13 pt. It's okay to the one cylinder. Let's discuss the cylinder arrangement which are connect two cylinders.
Sir,
Right? Okay.
sir,
Write down the problem. Another problem. Write down the another problem. Okay.
sir,
A cylinder of mass 16 kilogram, mass 16 kilogram, and radius 20 centimeter, is attached to a solid cylinder, of mass 4 kilogram, and radius 10 centimeter. Like this. First solid cylinder 20 centimeter. It's having a mass 16 kilogram, and other one 4 kilogram, 10 centimeter, 4 kilogram. Right. They can rotate smoothly along common axis which passing through their center. A mass of 10 kilogram, hangs from a string wrapped around the large cylinder. Wrapped around the large cylinder and mass 4 kilogram, hangs from this string, placed oppositely around the smaller cylinder. Oppositely around the smaller cylinder. Oppositely around the smaller cylinder. Okay. Okay. Okay.
Okay,
Then
sir.
write down the draw this diagram. 10 kilogram and 10 kilogram is hang from 16. Four kilogram. Okay. Draw this one. Okay. Then write down number one. Number one. What is the moment of inertia? Number one. What is the moment of inertia? Inertia moment of inertia of the cylinder system of the cylinder system of the cylinder system. Number two, what is the linear acceleration? What is the linear acceleration? Linear acceleration of each mass of each mass if the angular acceleration of the cylinder system of the angular acceleration of the cylinder system is alpha. That means the angular acceleration of the cylinder is alpha. What is the direction of rotation? It's this direction, no? Alpha. RAD S minus 2. We have to take the connection between the this accelerations. It come in the downward with A1. It go upwards into A2. Okay. Number three. What is the angular acceleration of the cylinder system and the linear acceleration of the each mass?
Sir, linear acceleration.
Number three. What is the angular acceleration of the cylinder system the linear acceleration of each mass, the linear acceleration of each mass and the tension in each string, and the tension in each string, tension in each string. We have to get the numerical values, not the connection. Number 3, number 4, write down. Okay, let's do that thing. Yes, let's do that things. Okay, I think clear, no? It's very easy. We have to use tau equals. First of all, we have to get the connection, the acceleration, and the angular acceleration. Angular acceleration. Then we have to apply the F equals ma to this one and F equal ma to this one, and tau equals I alpha to the system. Okay. Find out. It's a bit similar to the 2023-50 problem. In 2022, I had made this problem because these problems are, I think, advanced, like a little bit advanced, but we have to do this one because in the examination they are asking this one as the final questions. Okay. In 2024, what is the problems? 2024, the friction. Friction, it bit similar to the 2011 problem. Okay. That's why we have to do the advanced problems. Initially, we have to take the connection between the A and alpha. Number 1, A equals R alpha. A equals R alpha. Therefore, A equals R alpha. Considering small cylinder, A equals not small, considering 10 kilogram, 10 kilogram. A1 equals R mean the radius 20 centimeter, that means 0.2 alpha. 0.2 mean the radius into meter, 20 centimeter. 4 kilogram. Consider 4 kilogram. A2 equals 0.1 alpha. Okay, that's thing, I think, easy. After that, we have to do yes, kgm square A equals 0.2 into alpha. Yes. Okay. Then number 2, we have to take the I value. I means the total I value. That means the I small cylinder, I large. Small cylinder means mr square over 2. mr square over 2. That means m means the 4. 4 into r means 0.1. 0.1 square over 2 plus 4 plus 16. 0.2 square over 2. That means what's the answer? 0.2 square means 0.01. That means 0.02 plus 8. 8 into 0.04. 0.02 plus 0.032. That means 0.34 kg m square. 0.3 kg m square. I think it's clear, no? Yes. Yes, your answer is correct. Then we have to find the accelerations of the. We can simply apply. I take this tension as the T1 and this tension as the T2. I can apply F equals ma to 10 kilogram down. What is the force values? What is the values of? We can apply there is a weight 10 kilogram in 100 minus T1 equals 10 into A1. Apply F equals ma to 4 kilogram. That means T2 minus 40 equals 4 into A2. Okay. We can apply A equals R alpha. We find, no? Therefore, 100 minus T1, 10 into A1 means 0.2 alpha. 0.2 alpha. Previously, we discussed that. That means 2 alpha 100 minus T1 is number 1. Then it also can be applied 4 into A means A2. A2 means 0.1. 0.4 alpha T2 minus 40. Number 2. Okay. Then I apply tau equals I alpha to cylinder system. Then I can get apply tau equals I alpha to cylinder system. Tau equals to what? T1 rotates this direction. T2 rotates this, try to rotate this direction. That means we have to take the total summation of the moment. Total summation of the moment. It's very simple. T1 into 0.2 meter, T2 into 0.1 meter. Likewise, that's very easy. So means T1 into 0.2, T2 into 0.1. Okay, equals I alpha. I mean 0.34. 0.34 alpha. Alpha means alpha. Yes. It's number 3. That means we can multiply by 10. 2T1 minus T2 equals 3.4 alpha. Okay. We have to add them all. Right? I take the first one, 2T1, this 2T2. I had multiplied first one into 2 and add it to the second one and add it to the third one. In this case, we can get the one line. Okay, එක line එකකින් ගන්න පුළුවන්. හරි. answer එක. Right. Therefore 200 minus 2t1 equals plus 2t2 minus 40 plus 2t1 minus t2. 2 alpha means 4 alpha, 0.4, 3.4. Correct. Therefore 200 minus 40, 160. 4 alpha, 0.4 alpha, 4.4 alpha, 4.4 alpha, 3.4 alpha. That means 7.8 alpha. Alpha equals 160 over 7.8. 7.8. That means 20.51. Yes, your answer is correct. 20.51 RAD is minus 2. Then the acceleration A1 equals to 0.2 alpha. Yes, your answer is correct. 20.51. 4.103 ms minus 2. A2 0.1 mean 2.51 2.051 ms minus 2. That's correct. Then T1, how to find T1? We have to apply this equation, right? Apply this equation. T1 equals to from number 1, 100 minus T1 equals 2 into alpha mean 20.51. T1 equals 100 minus 20114. T2 mean second. T2 minus 40 equals 0.4 alpha. Okay, 0.4 alpha mean 0.4 into 20.51 minus 40 T2 equals 40 plus 0.4 20.51. Yes, your answer are correct. $58.98 Newton. $48.2 Newton. Yes, your answer are correct. Okay. Then okay, write down the topic. angular impulse. Angular impulse. What mean by the angular impulse? In linear motion, when we apply force in short time period, that means the impulsive force, we can define the impulse, right? What is the mean by impulse? Write down. When there is an external torque, write down. When there is an external torque, there is an angular impulse. There is an angular impulse. In linear motion, what? Linear motion. We know there is formula I equals to Ft. Likewise, the rotational motion. It also the impulse we can take as J or I. It's not a moment of inertia. Impulse I equals Ft mean the torque T. Torque mean the, in this case, torque mean the force, like this force, this is the torque. Because of that, this one is the I is used for the previous one also. We have take the as J equals tau. Then we can apply if what is the another equation? F equals delta mv over T. F equals delta mv over T. Ft equals delta mv. Ft equals delta mv. Likewise, we know tau equals delta I omega over T. I think you can memorize that. Likewise, in this case, tau T equals delta I omega. Right. Therefore, I can be taken as the Ft delta mv. Likewise, the impulse is equals to the force into time. That means the moment of change in linear motion. We discuss that one. Linear motion. We discuss that one. Likewise, in this case, J equals what? J equals tau T delta I omega. Okay. Write down this one. Okay. Write down this one. Write down these things. Write down when we apply external force as a point. When we apply external force to object, external torque to object, it got angular acceleration. It got angular acceleration. It got angular acceleration. Therefore, do you know angular impulse mean? Angular impulse equals delta I omega. Therefore, we can say angular impulse equals delta I omega mean it got acceleration mean I2 omega 2 minus I1 omega 1. Right? Right down. Most of the cases, the I does not change, but when the when I is changed, we can apply this one. Okay. Write down the problem. Write down the problem. Cylinder having a moment of inertia. Cylinder having a moment of inertia. I equals 0.8 kg m square. Cylinder having a moment of inertia I equals kg m square. Find the time taken. Find the time taken to increase the angular velocity eight radius 8 radians per second to 12 radians per second. 12 radians per second using 1.2 Newton meter torque. 1.2 Newton meter torque. Okay, find out. To that problem, we have to only use the angular impulse means the change of the momentum. That means angular impulse tau into t equals to delta I omega. I does not change. Therefore, I omega means the final angular momentum minus initial angular momentum. That means 0.8 into 12 minus 0.8 into 8, right? So T mean 1.2 into T means, yes, we have to take the T. That means 0.8 into 4, 1.2 into T equals 0.84 over 1.2. Yes, 3.2 over 1.2, 32, 12. Yes, what is the answer? Yes, your answer is correct. 2.67. 2.67 seconds. Yes, answer is correct. Huh? Good. Then write down what mean there is a external resistive torque when we rotate in the fan, or rotate in the disc. When there is an external resistive torque, the angular velocity get reduced. That mean කියන්නේ අපි මොකක් හරි කරකවනකොට ඒකට රෝදයක් ගන්නකො රෝදේ කරකනකොට ඒකට බ්‍රේක් ඇල්ලුවොත් එහෙම නැත්නම් කියන්නේ පැත්තින් ඇල්ලුවොත් එහෙම අපි රෙසිස්ටිව් එකක් දෙන්නේ. එතකොට එයාගේ මේ ඩීසලරේෂන් එකට යන්නේ. හරි? write down when there is a resistive external torque, when there is a resistive external torque, when there is a resistive external torque, angular deceleration may occur Okay. What mean by angular? That mean the angular impulse reducing the angular velocity. Therefore, we have to the initial angular velocity is higher. Therefore, initial J mean delta I omega. That means the angular impulse is equals to the change of the momentum, angular momentum, initial angular momentum, final angular momentum. Okay. J mean I1 omega 1 minus I2 omega. Okay. Write down. Okay. Then write down the problem. After applying, write down the problem. After applying 10 Newton meter resistive torque, after applying 10 Newton meter resistive torque in 10 seconds, to solid cylinder, the angular velocity decreases, 20 RADS minus 1 to 20 RADS minus 1 to 12 RADS minus 1. 12 RADS minus 1 time equals to 10 seconds. 10 Newton meter resistive torque in 10 seconds. 10 seconds में क्यों है? Torque equals 10 Newton meter. अरे पे ब्रेक क्या अप्लाई करना आगे? Find out the moment of inertia. Okay, fine. Right. මේකේ අපිට ලියන්න පුළුවන්. So angular impulse equals tau t equals to moment of change of momentum, angular momentum. Tau t means 10 into 10 equals I omega mean I into omega 1 mean 20 minus I into 12. That mean I into 8. 100 I equals 12.5 kg m square. That's the answer. Okay. Then write down topic, main topic, principle of conservation of principle of conservation of principle of conservation of angular momentum. Right. In linear motion we know when there is a no external force, when there is a when there is no external force, we can use the uh, conservation of uh, principle of conservation of linear momentum in any direction if there is a no external force. The linear momentum is constant in the direction that not applying the force. Likewise, there is also the in a rotation motion also there is a principle of conservation of angular momentum. Linear motion, linear rotational, right? In linear motion, we know F equals delta mv over t. Rho equals delta I omega over t. When the give me 1 second. Okay, in rotational motion, we can take this one. If there is a no external force, F equals 0, we can simply say delta mv equals 0. If there is no torque, tau equals 0, delta I omega equals 0. Therefore, the delta I omega mean delta I omega equals 0. Therefore, delta I omega 0 mean I1 omega 1 minus I2 omega 2 equals 0. Therefore, I1 omega 1 equals I2 omega 2. In this case also, M1 V1 minus M2 V2 equals 0. M1 V1 equals M2 V2. Right? Therefore, the initial momentum equals to final momentum. Therefore, the initial angular momentum equals final angular momentum. Right? Okay. Write down this one. Okay. Write down that
that in definition, the total angular momentum, definition of the principle of conservation of angular momentum. The total angular momentum of a system remain remain constant remain constant remain constant remain constant. The direction which have no external torque, which have no external torque, acts on the system, acts on the system, acts on the system. Okay. Then write down application of application of write down application of principle of conservation of angular moment. Angular moment applications. Right. Remain constant. That means the angular momentum is remains constant. Right. When I get increase, omega get decrease. Why? I increase, omega decrease because these are constant. I decrease, omega increase. I decrease, omega increase. Right? Therefore, I1 greater than to I2, the omega 1 smaller than to omega 2. I1 smaller than to I2, the final in moment of inertia is higher. The omega 1, omega 2, it get reduced. Right? When we take the two masses and we rotate, we take the two masses on both hands and we rotate. හරි අපි මෙහෙම මෑස් දෙකක් අරගෙන rotate වෙනකොට අපි කැරගෙන ස්පීඩ් එකයි අපි අත් දෙක ලං කරොත් එහෙම කැරගෙන ස්පීඩ් එක when we get closer to the body hands are get closer to the body, then we rotate, the velocity getting increase. දැන් කියන්නේ අපි මෑස් දෙකක් අතේ තියාගෙන මෙහෙම කැරගෙනකොට අපි මෑස් දෙක ලං කරගත්තොත් එහෙම මේ velocity එක වැඩි වෙනවා. හරිද? ඒක application of principle of conservation momentum. Right. Write down this one. If there is no external okay. Write down this one. Okay. Write down an ice skater හරි ice වල යන්නේ plane skater rotating in ice slow with his hand extend. his hand extend. Right? May I rotate now? Right? When just remember when after a small time, he bring his hand closer to his body, closer to his body, he will rotate, faster, according to the principle of conservation of linear momentum. According to the principle. The previously I1 then I2, we know I1 is greater than to I2, right? The mass distribution is higher in this case. Therefore, omega 1 and omega 2, we can simply say omega 1 should be greater or less than to this one. This one less than to this. Okay. Okay, write down this one. Who is problem? Who is problem? A cylindrical plate, having a mass capital M, having a mass capital M, and radius capital R is rotate omega R radius minus 1 then the clay ball, then a clay ball of mass capital M over 8 is dropped to the edge of the plate, to the edge of the plate, and it stick to the plate. Initially, it's rotate the omega. Right? Initial මෙහෙම rotate වෙවි තිබ්බ එක්කෙනාට tick වෙනවා මෙන්න මෙහෙම clay ball එක. Find the final omega. Find the final angular velocity. Right? මෙහෙම rotate වෙවි තිබ්බ එක්කෙනාට මෙහෙම එක්කෙනෙක් වැටෙනවා. එතකොට final velocity එක අහලා තියෙන්නේ. මේක m radius එක r. Okay, find out. We have to apply conservation of angular momentum like the previous linear momentum. Very easy. Find out. We have to take for this case the initial I equals m r square over 2. The final I equals to I1, I2 equals to what? M r square over 2. But this thing is attached to the edge of the cylinder. Therefore, it gave the extra moment of inertia. That means we have to add m over 8, the distance m r square, r square, r square, m r square over 2, m r square over 8. That means we can take 8 as the common, and this is 4 m r square plus 5 m r square. Okay, 5 m r square. Therefore, we can use principle of conservation of angular momentum. Right. I1 omega 1 equals I2 omega 2. Right. I1 means the mr square over 2. mr square over 2. Omega equals 5 mr square over 8 into omega 2. mr square cancelling out. It is 8 omega over 2 omega 2. That mean omega 2 equals 4 omega. Omega 2 equals 4 omega. Okay, 4 times omega. Five into 8 5 මෙතන 10 එනවා. Sorry, මෙතනට 5 එනවා. 5 into that means 10.8 omega නේ. 8 omega over 10. That means 0.8 omega. This is correct because the I get increase, the omega get decrease නේ. omega අඩු වෙනවනේ. කලින් එක ආපු එක වැරදි. omega අඩු වෙනවා. හරි. Then let's do the another problem. A merry-go-round has it means merry-go-round has 100 kilogram and diameter 8 meter. Diameter 8 meters. The radius of gyration is 3 meter. A child of mass 20 kilogram. Runs with a velocity of 5 ms minus 1. towards the outer edge of merry-go-round, towards the outer edge of merry-go-round, and jump into the outer edge of the merry-go-round, jump into the outer edge of the merry-go-round, which is in stationary, which is in stationary. Find out the final angular velocity of the system. Find the final angular velocity of the system. It's like this, but the child is jump into the merry-go-round with the velocity. Therefore, how can we find this case? There is a merry-go-round, 100 kilogram, 8 meter low. A child mass 20 kilogram is connect 20 kilogram is connect with 5 ms minus 1. Okay, the final velocity. Okay, find out. Give me the answer. Initial, we have take initial angular momentum. What is the initial angular momentum? The child is running from this end. We have to take the angular momentum. Angular momentum. The concept of angular momentum is moment of the linear momentum. Moment of the linear momentum is angular momentum. The linear momentum of this child is m into v, mass mv. The moment mean moment of momentum. Moment is this one into 8 into r, 8 mv into 8. Mass is 25 into 8. That means 100, 800. 800 the momentum. Kg ms minus 1 kg m square rad s minus 2 s minus 1. Okay. We have to apply. Then after that, we have to take I value. Final I2 equals the radius of gyration is 3. The momentum, the moment of inertia I equals m k square. That means 100 into 3 square. That means 3 square mean 6. Sorry, 3 square mean 9. 9 kg m square, right? Like that. We have take I2. I2 equals to what? The child is connected to this one. Therefore, I1 plus I child. That means 900 I child means MR square. MR square means 20 MR square. MR square. 920 R square means 8 square. 920 64. 900 so 640 like that. Then we have to apply conservation of principle of conservation of angular momentum. Initial angular momentum. Initial angular momentum. Final angular momentum. Right. Therefore, what is the final I value? Uh, One initial angular momentum is 800. Final angular momentum is I is this one. The omega is omega final. Omega is 800 over. Let's think. Let's take this one. Point 367. Yes, your answer is correct, but decimals are not correct. Na? RAD S minus 1. RAD S minus 1. Write down the topic. The vector type of angular momentum. The vector type of angular momentum. Vector type of angular momentum. Right. In that case. Right. Since the angular momentum is vector, the magnitude in constant and only the direction change constant and only the direction change is enough to affect the change of angular momentum. The change of angular momentum. The change of angular momentum. This can be shown in the cycle wheel. Right. Listen carefully. In there is a man who is in the chair. It can rotate. can rotate. This man is having a rotating wheel. His hand having a rotating wheel. It rotating in this direction. Rotating in this direction. Right? What is the direction of angular momentum? What is the direction of angular momentum? It's rotating in this direction. We have to take the right hand rule. Right? It's rotating in this direction. Omega in this direction. Therefore, L in this direction. L in this direction. Right? Then this man is on the chair, right? Not connecting with the earth, right? Then this man is changing. This man is changing the direction of the cycle wheel. This is cycle wheel. I will put the example also. It rotates, right? Rotate the rotate mean upside down. Getting upside down this wheel, like therefore it rotates in this direction. Previously it rotate in this direction. Is rotate in this direction. It's rotating upside down. Therefore, what is the L value? L in this direction. L in this direction, right? Have to apply the right hand rule. L, it rotates in this direction. L is in this direction. Okay. Okay. What should be happen? L in this direction. What should be happen? දැන් මේ වගේ වෙලාවට මෙයා කැරකුවොත් එහෙම මේක පුටුව කැරකෙන්න ඕනේ. හරි? Why? Why? Angular momentum of system L in upper direction, right? When what is the direction of this one? Angular momentum of system in this direction, downward direction. But angular momentum is conservative. That should be conservative. Therefore, because of that, this chair is rotating in this direction. Right? Chair is rotating in this direction, keeping the angular momentum as constant. L in upper direction, L in this direction. So this chair should be rotate having a 2L in upper direction. Why? The angular momentum of the system should be remain. හරි මේක remain වෙන්න ඕනේ. එතකොට මෙයා L downwards නේ තියෙන්නේ. It is L downwards. It's at L upwards. Therefore, the chair also rotate in this direction with 2L angular momentum. Hare. Final angular momentum is L upwards. Okay. Right. First of all, you have to draw this one. Draw this one. Angular momentum of wheel. Now L downward, right? L downward. The angular conservation of angular momentum by applying conservation of angular momentum, we can say initial angular momentum same to final angular momentum. Initial angular momentum L upwards, final angular momentum L downwards, and L chair. L chair equals L upwards. I put this one to this direction, L downwards. Therefore, L upwards plus L upwards, 2L upwards, right? L chair is 2L upwards, right? Write down. It's clearly. I will give the example also. Write down this one. Okay. The chair having a 2L into upper direction. Okay. Series video. This one shows the angular momentum change. Huh? See. When bringing the mass inwards, the I get increase, I get decrease. I get decrease mean omega get increase because I omega is constant. I omega is constant. I omega is constant. Therefore, this is the small example. In this case, this is the similar case which we discussed. This is a bicycle wheel, and she held this one in hand in one direction, but it turns the another direction. The angular momentum should be conservative. It rotates another direction. Okay. This is the example. This is the example which I had discussed. Okay. Right. Then write down the problem. Write down the problem similar to this one. A man sitting on a chair. A man sitting on a chair which can rotate without the friction. Which can rotate without the friction. About vertical axis. About vertical axis. About vertical axis. Shown in figure. Shown in figure. Has total total moment of inertia, total moment of inertia of the chair, including the man, is 6.8 kg m square. 6 kg m square. A wheel which having the moment of inertia 1.2 kg m square, which having the moment of inertia 1 kg m square, rotates about vertical axis, vertical axis again hold man hold a wheel moment of inertia man hold අතේ තියාගෙන ඉන්නේ moment of inertia 1.2 kg m square is rotate about vertical axis, is rotate about vertical axis, is rotate about vertical axis with 3.9 rpm. With 3.9 rpm. I equals 1.2. In this case, I equals man plus chair equals 0.68. Initially, the man and the chair are stationary. Initially, the man and the chair are stationary. When man rotates the axle of the wheel upside down, axle of the wheel upside down, calculate the speed at calculate the speed of the chair rotates with the man. Chair rotates with the man. This is a problem. Okay, find out if you cannot get that diagram. It's like this, huh? It's like this. This is the diagram. In that problem, there's telling the eye of the man and the chair is 0.68 kg square, right? And this wheel, the man hold the wheel, right? Hold the wheel. It having a rotational speed n equals 3.9 rpm, and the I equals this one. Therefore, we have to find the we have to find the angular momentum. Angular momentum, right? So for this case, the angular momentum in upward direction. First of all, you have to find that one. Then the man and the chair is stationary. When it rotates to upward direction, right? It rotates in 2.9, the L in this direction, right? This L in also in this direction. You have to find what is the direction of the angular momentum of the chair. We know we have to take the L in upwards, but now the L in downwards. No, we have to, after the final system, the L should be in upward. Final system L should be upward. Why? It should be similar to the initial one, right? Therefore, we have to find the L chair. Okay. We have to find the angular momentum of the chair and the man and find out the rotational speed of the chair. Okay. Find out. Okay. Initially we have to find the L value. How to find the L value? L equals I omega. I we know 1.2 omega equals to 2.19 RPM. We have to convert it into the RPS and we have to find the omega. 25 N. N mean 3.9 RPM. We have to divide it into RPS. Find RPS, we have to divide to 60. This is the initial L, right? Okay. L equals what? After find this one, we can say 1.2 into 25 into 0.49. 0.49. 0.49 kgm square RADS minus 1. Okay. This angular conservation of angular momentum. Initial one is this one. Initial angular momentum equals final angular momentum. Initial one is this one. Initial one is 0.49. Final one is this 0.49 acts downward. Upwards 0.49 acts downwards plus L chair. L chair. What is the L chair? This goes into this direction, 0.49 into up direction, upwards, into downward direction, L chair. L chair mean twice of this one. Why? These are vectors. This is equal to the adding of these vectors. I will show in this. L chair equals 0.49 plus 0.49 upwards. 0.49 into 2. It's 0.98. L chair is this one, but we know I of the chair and the man is 0.68. This is L equals I omega. I chair omega equals L chair. Plus man, plus man. Omega equals what? Omega equals L chair, 0.98 0.98 into I chair 0.68. Omega equals 0.98 over 0.68, right? 1.411. Yes, it is 1.411. I think there is a decimal mistake. Already it's minus 1. Your answers are yes, 0.411. Right. Write down rotational kinetic energy. Right. Rotational kinetic energy is equal to the when we take the rotating wheel, rotate O axis, it's equal to the when we consider the small mass m1, m2 and velocity v2, m3 and velocity v3, it's rotating. Likewise, we can take the large type large by likewise we can take the many particles, right? The rotational kinetic energy equals to the total kinetic energy of the all particles. Total kinetic energy means these velocities are what is the tangential velocities? It when it rotate the omega, these particles are getting what? Tangential velocities. Tangential velocities. Therefore, we have to take E total half M1 B1 square half M2 B2 square half M3 V3 square. Likewise, we can write down. That means half into M1. We can simply say V1 equals to R1 omega R1 omega. V2 equals to R2 omega. V3 equals to R3 omega. R4 omega. Right? M1 V1 equals R1 omega. M2 R2 omega. M3 R3 omega. Likewise, we can take half M1 R1 square omega square half M2 R2 square omega square half M3 R3 square omega square. Likewise, we take the omega and half as common. We can take M1 R1 omega square, M2 R2 omega square, M3 R3 omega square 3 dots. What is this? This equals to the moment of inertia. This is equal to the moment of inertia. Previously we discussed, no? This is sigma mr square I equals to 1 to n omega square over 2. That means I omega square over 2 into I. Right? Therefore, kinetic energy, total kinetic energy equals half I omega square. It bit similar to the kinetic energy of linear motion. Half mv square. Likewise. Okay. Okay. Write down after write down the topic rotational kinetic energy and write down consider the object rotating around, consider an object rotating around an axis, rotating around an axis, rotating around an axis through a fixed point, through a fixed point, fixed at center, at center. The object having angular velocity omega, the object having angular velocity omega, object having angular velocity omega, let particle m1 comma m2 comma m3 comma dot trees, three dots, which having the distance from the center, which having the distance from the center, symbol r1 comma r2 comma r3 comma three dots, from the tangential speed v1 comma b2 comma b3 three dots. Right. Write down this one. Okay. Put it. Write down a small problem. I'm giving all the problems to the theory, and if you go into the note, you can get an idea. No need to memorize or something, right? Again, watch the video. No need to, right? A uniform cylindrical plate. A uniform cylindrical plate. Write down a uniform cylindrical plate having moment of inertia. Moment of inertia. I equals 18 kg m square. 18 kg m square. If rotational kinetic energy, if rotational kinetic energy is 180 joule, 180 joule, 180 joule, find out the omega. Find out the omega. Find out the omega. I equals to 18 kg m square. Kinetic energy 180 joule. Omega. Find the omega. Okay, find out the omega. Give me the answer. -1. Right. Kinetic energy equals to I half I omega square. Kinetic energy 180 half into I mean 18 into omega square. That means 10, 20 omega square. 20 omega means 20 root. That means 4 root 5, no? 4 root 5. That means is that correct? 8.994. 8.944. RAD S minus 1. Okay. This is the answer. Okay. It's very easy because this one is bit similar to what? Kinetic energy. Linear motion. Linear motion. Kinetic energy equals what? Half mv square, half mv square. It's very easy, half mv square. Okay, but in this case, m is equal to moment of inertia. You know, v is equal to omega, right? Likewise. Okay,